Hello, my fellow friends. So today our group would like to present about properties of relation. So let's move to the introduction of our team members. So my name is Nazira binti Marabi. With my ID number is 2024 794 353.
My name is Nordiana binti Zulkifli and my matrix number is 2024927045.
My name is Intanu Shafira binti Isa and my matrix number is 2024554513.
My name is Noshaza Izati binti Muhammad Salihin and my matrix number is 2024542715.
So there is several topic that we want to discuss in our slide, which is the first is background study, the second is problem statement, the third is coding demonstration, and the lastly analysis result.
Next, for our background in group project. First, we choose this topic because we love discrete mathematics and computer science application, and also building a program help us learn by doing. Second, relations are crucial in discrete math, important for understanding structure and algorithms, and used in database theory and graph theory. The last one, our goal is to develop a program that checks if relations have reflexivity, symmetry, and transitivity and can generate the necessary closures.
So let's move to the problem statement. So we have 4 problem statement in here. Start with input handling. The first is read input data from various source, including text file, console input. It will pass and represent the set of elements and their relation. The second is property evaluation. Check and display if the relation within the set are reflexive, symmetric, and transitive. And then the third is closure computation. Compute and display the reflexive, symmetric, and transitive closure of the given relation. And then lastly is output. Clearly indicate whether the original relation are reflexive, symmetric, or transitive. It will display the generic closure and indicate the properties.
Okay, so this is our coding, which is the relations coding. So the first thing we have coding for read the relation from console input. So this is the coding. And also it will display the elements and relations. So this is the coding of display elements and relations. And then this is the coding of to check if our relation is reflexive, symmetric, or transitive. Okay, so we have used the function of boolean to check whether that relation is reflexive, symmetric, or transitive. So to generate the reflexive, symmetric, and transitive closure of the relation, so this is the coding. So we use the function named reflexive closure, symmetric closure, and also the transitive closure. So next, to determine the properties of the relation, so we use the function of void and also the boolean to check whether the set properties are reflexive, symmetric, or transitive. So if the relation is not reflexive, symmetric, and transitive, so it will display none at our system. Okay, so this is our interface of the system. Okay. So first we need to type console, and then if we type other than console, so it will display the invalid choice. Okay, so let's run our system. Okay, so the first thing that we need to do is type console to start the system. Console, and then press enter, and then we need to enter the relations. Let's say relations 1, 2, and 2. So each line we need to put the number vertically, and each line consists of 2 numbers which separated by a space. So if we have done to insert the relations, Then we need to type done, and then it will display the set of elements of our relation, which is 1 and 2, and set of relation is 1, 2, 2, 1. So the set properties are symmetric. Reflexive closure is 1, 2, 1, 2, 2, 1, 1, 1, and 2, 2. So for symmetric closure is 1, 2, and 2, 1. And lastly, the transitive closure is 1, 2, 2, 1, 1, 1, and 2, 2. So let's say if we type other than console, let's say hi. So our interface will automatically display the invalid choice and then stop the system. If we type other than console, let's say hi. So our interface will automatically display the invalid choice and then stop the system. If we type let's say 1 and 2, 2 and 1, and type other than done, let's say world, so it will display the message of invalid input, please enter two elements separated by a space.
The objective of this project is to develop a program that takes a set of elements and their relationships as input. Once the user provides the set of elements, the program will analyze and determine whether the relation is reflexive, symmetric, or transitive. Additionally, the program will compute and display the reflexive closure, symmetric closure, and transitive closure of the relation. Consider an example where the relation R is given by 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, 4, 4. According to the definitions of reflexive, symmetric, and transitive relations, we can conclude that R is reflexive, symmetric, and transitive. This conclusion is drawn because R satisfies all the criteria for reflexive, symmetric, and transitive relations. Furthermore, a closure of a relation involves adding any missing parts to satisfy these properties fully. In this case, since R already meets all the required properties, it does not require any closures. Thus, R is not only reflexive, symmetric, and transitive, but also qualifies as an equivalence relation. For another instance, if the user inputs a relation R 1, 1, 2, 1, 2, 2, 3, 1, 3, 2, and 3, 3, the program will determine that the relation is reflexive and transitive. This determination arises because the provided elements satisfy the rules of reflexive and transitive relations but do not meet the criteria for a symmetric relation. Consequently, the output will include only the reflexive and transitive closures. A relation is reflexive if AA is an element of R for every element A, element of A, symmetric if BA, element of R, whenever AB, element of R, for all AB, element of A, and transitive if whenever AB, element of R, and BC, element of R, then AC, element of R, for all ABC, element of A. In conclusion, the output generated by the program depends on the elements entered by the user. The program will display the relation properties that are fulfilled based on the input elements. If the entered elements meet the criteria for any of the relation properties, the corresponding output will reflect the satisfied relation rules.